Greetings, my physics students. Good morning, good afternoon, and good evening, depending on where you're watching me from. Welcome back to this channel. This is video 5 of the Simple Harmonic Motion series. We've discussed a lot of things in the series, and in this video, we want to round off the topic. And before we begin, if you have not subscribed to this channel, before you start watching the video, click on that subscribe button there by your right hand side there, and then there's a bell icon, a bell beside it. Just tap on it, and then you will be always notified anytime we post a new video. Now let's round it off. We have solved some questions under this topic. I want to bring up a question under that topic, simple harmonic motion. So let's solve this question. A spring of force constant 500 Newton per meter has a load of mass 4 kg hung from its end. Full stop. If it is made to oscillate with amplitude, so let's take our amplitude to be 10 centimeters. Calculate the maximum, or rather, let me put it like this. Let's solve for angular velocity, linear velocity, total energy, then maximum acceleration. So let's quickly look at this question and then round off the topic. Then you can go to your textbooks, solve questions using the formulas I've given you. Now let's begin. Solution. It says a spring of force constant 500 Newton per meter. What is force constant in the table that I gave you? Force constant is K. So K is 500 Newton per meter. Are you following? Has a load of mass 4 kg. Load mass is M, hung from its end. If it is made to oscillate with amplitude 10 cm, amplitude is capital A, so we have capital A is 10 cm. I told you that anything cm, change it to meters. So 10 over 100 is 0.1 meter. And then I have to clean this so that we do our calculations here. So the first question is, we are supposed to find the angular velocity. What is symbol of angular velocity? Check that table you have. I gave you video 1. It is W question mark. Now let's solve for it. The W I gave you, there are different formulas, about 5 formulas I give for W. But based on the data we have here, the one that can solve it is W is equal to square root of K over M. Square of what? K over M. Okay, so now we substitute. Now we have W will now be square root of, what's our K? Our K is 500. Our M is what? 4. So if you do 500 divided by 4, you will get 125. So let's get the square root of 125. Square root of 125 is 11.2. So I have 11.2. You make sure you put your unit of W. Check your table for the unit of W. Radians per second. That's unit. Is it clear? So I have solved the first one now. Now let me solve the second one. Linear velocity. What's the symbol of linear velocity? Symbol is V question mark. And you know I told you can use this formula WA. I gave you this formula. You can use it. So now V will be, our W is 11.2 times A. Our A is amplitude, 0.1. So it will give us 11.2 times 0.1 is 1.12 meters per second. Just apply the formula. It is very simple. All right. Then the number 3 is the third one is max total energy. What is total energy? Check that. There's a formula I gave you that says maximum kinetic energy is equal to maximum potential energy and is equal to total energy and is equal to half Ka squared or mgh maximum squared, right? So now we have, let's solve for total energy. Total energy, you can use half Ka squared or half or mgh maximum. But since this one is not going to work, let's use this one because we have K and we have A. So I cancel this one. And the formula is going to be half times, our K is 500. Our A is 0.1 squared. So if you multiply them out, half times 500 is 250. 0.1 squared is 0.01. Multiply this to now, you get 2.5 joules. Okay, 2.5 joules. That's total energy. Then finally, we are looking for maximum acceleration. What is the formula for maximum acceleration? What's the formula for maximum acceleration? Let me call it A max. A max is maximum acceleration. We use negative omega squared A. Negative omega squared A. I told you that negative is not involved in the calculations. It shows you that the acceleration is directed towards the center of the path of oscillation. So our A max will now be, our W is 11.2 squared times A. What's our A? 0.1. 11.2 squared times 0.1. Okay. We're going to have 11.2 squared times 0.1. 11.2 squared gives me 125.44. So A max 125.44 times 0.1. If you multiply them now, you have 12.544 meters per second squared. Is it clear? So what I would advise you to do is that use those formulas I gave you in video 1. Check questions in your physics textbooks under simple harmonic motion. You can use this textbook they call all-inclusive calculations in physics. You can get it. Then check simple harmonic motion and solve all the questions in the exercises. All the formulas I've given you can take care of the questions. Okay, so this is officially the remaining video of simple harmonic motion series. If you have learned something from this video, if you have learned good things from this video, please don't forget to drop a like on the video. And if you have not followed the channel, click on that subscribe button there to follow the channel so that anytime we post the next video, you will be notified. Our next video series will now be on linear momentum. linear momentum, or rather we will first treat Archimedes' principle, equilibrium in liquids, before we now treat linear momentum. But check out for the next video. Once it drops, you'll be notified once you have subscribed. So thank you very much for coming around. I'll see you.